Okay, this is just a review of some characteristics that you're getting from basics of exponential functions. So your big key things here is you want to be able to identify these two quantities, the base and the y-intercept of an exponential function. That's what your goal is off of an equation. So there's kind of two pieces. Again, you got your base, you got your y-intercept in your exponential equation. Now, just to recap, like this is more general. The y-intercept is what we're talking about. We're talking about the y value. Always for any function, it's when the y value when x is equal to 0 because it's on the y-axis. So let's talk more about that as far as algebraically before we get into the base. When we talk about your exponential function, your y equals a times b to the x power. The y-intercept comes from what you saw hopefully in the gizmo, is that the y-intercept is coming from the a value. So a is the y-intercept. So it's 0, comma, a. So I'm just going to kind of set that out because that's the most important piece here. So why is the y-intercept always 0, comma? Why is it that a value? Well, again, let's think of our definition. If we take our general form here and we plug in x equals 0. So remember our definition said when x equals 0. Anything to the 0 power, so the 0 applies just to the b here. Anything to the 0 power is 1, so it's a times 1, so it's just a. So there's your y-intercept. That's why the a value is the y-intercept when it's in that general form. Now the base, the b value there is the product, what we're multiplying by, that causes the change. So when we looked at the zombie outbreak, the zombie attack, we had 2 to the x. Sorry, that was my phone. We had 2 to the x, and so 2 to the x was causing the change of times 2 times 2. We were multiplying by 2 over and over and over again. So that's your base times 2 again. That's your base value. So y equals a times b to the x again. Just the b value is the base because that's all that's being affected by your choice of x variable. Okay, so that's algebraically what it's going to look like in our equations. Now, graphically, if we look at a sketch of an exponential function, our y-intercept, so I'm going to draw just kind of a generic exponential function here, exponential growth. Our y-intercept, I'm going to circle this, is 0, comma, the a value. If we're looking at our graph, obviously that's where we're going to be looking for our y-intercept. A is the y-intercept value. Now for my base, it's not quite as straightforward to see, but hopefully we can make some sense of it. If I have, and you guys did a little bit of this in the gizmo, if I have a point here, so I have my y-intercept at 0, comma, a, and I have a second point, so there's my y-intercept, at 1, comma, and whatever this value happens to be. That's actually all the information you need in order to figure out what the base was. And actually it doesn't even have to be those 2 points, but it has to be 2 consecutive points. The base, the b value here, maybe it would help if I wrote a table out. We have 0, comma, a, and we have 1, comma, y. The base is always going to be this change. So how did I go to, what number, what product am I using to change from one value to the other? So how do I figure out this number? It would actually just be that I take the y value and divide it by the a value. That would tell me what I needed to multiply by. So if, for instance, if this was 2 and this was 6, I could tell what the change was here by doing 6 divided by 2. So times 3. You don't necessarily need to write out those numbers. I would just keep it as the variables there. But so you can see where that comes from. Okay, last piece numerically, what the y-intercept and the base look like. Again, if you're looking at numerically, we're talking about our table values. So it's when x equals 0, the y value is what our intercept is. So the y value is the y-intercept. So I'm just going to put a couple of short examples here. We're looking at a table, and you've got -1, 1/2. You've got 0, 1, 1, 2, 2, comma 4. There's your y-intercept. So the a value would be 1. You've got a second table here. Let's just get some different values here. -1, 2/5. 0, 2, 1, 10, 2, see if you can see the pattern, 50. Our a value comes from where x is equal to 0, so a would be 2. So you may not have all of these tools or all of these pieces, but generally speaking, you'll have at least one of them. So now when we look at the base, kind of like what I alluded to in the last one, to figure out what that b value is, you just need to figure out what the product is that's causing the change. So I think we have the same numbers. Yep, 1, 2, 2, 4. So we look at the change. This is times 2, times 2, times 2. So that means our b value, our base value, is going to be 2. For the second table here, we're going to have slightly different numbers. We're going to go -1, 3, 0, 1, 1, 1/3, 2, 1/9. So that means our b value is going to be the product, and so it was important that it said the product. So we're going to think, what do we multiply by here? We divide by 3, but we multiply by 1/3. So times 1/3, so that means our b value is 1/3. So just to kind of summarize the things you saw, some in the gizmo, but also just looking at that equation, that y equals a times b to the x, kind of thinking about how are we going to write those and how are we going to interpret them.